Hello class, welcome to Algebra Lesson 8.4, which is all about quadratic equations. By the end of this lesson, you should be able to factor trinomials of the form ax squared plus bx plus c and equations of that same form. So yesterday we solved just the x squared plus bx plus c, but today the difference is now we have a number that isn't 1 in that location where the a is. So if we want to factor this polynomial, if we start with letter A, 5x squared plus 13x plus 6. So the way that you're going to solve these is, you know how yesterday I had you take whatever this last value was, and then you would split it up and say, what are the factors that go into that number? Today, it's that same process, but there's one step before you can do that. You actually take whatever that a value is with your x squared, and you multiply it with that last value that we were using yesterday. So you do a times c if you're looking at the general formula. So I'm going to do 5 times 6, which is 30, and then I'm going to list my factors of 30. So I have 1 and 30, I have 2 and 15, 3 and 10, 5 and 6. Now I go through those and I say, which of those factors add up to 13x? So 13x, that's going to end up being a positive 3 and a positive 10. So I'm going to draw my box. Here's my box. Not a very good one, but you get the point. And I'm going to write 5x squared. And then I'm going to write 6 in that same spot. And the two numbers that you found over here can go in either of the remaining two boxes. So I'm just going to say positive 3x here and a positive 10x there. So now, again, I start by looking at this vertically. And I say, what do these two boxes have in common? 5x squared and 3x both have an x in common. So if I pull out an x, I'm left with 5x, and I'm left with just a 3. Now that I've looked vertically, I'm going to look horizontally. And I say, okay, I have 5x over here. What do I have to, if I took a 5x out, what am I left with over in this other box? Remember, when we take things out when we're factoring, that's like dividing. That's not subtracting. So 10x divided by 5x would just leave me with 2. So if I took 5x out, I'm left with 2. And then just to check, I'm going to say, is 2 times 3, so are those two positions, does that match my last box? So 2 times 3, is that 6? Yes. So I know that I have x, and then I had a positive 2, and I had 5x and a positive 3, and that is my answer. Okay, now let's move on to the other side over here, and I have 6x squared plus 22x minus 8. Now, before I even jump in and say what is 6 times 8, I am going to remember what we learned back in 8.1, which was greatest common factor. And I see these are all even numbers. That means they can all be divisible, or they're all divisible by at least 2. So if I pull a 2 out, I'm left with 3x squared plus 11x minus 4. And now they no longer have a greatest common factor. So I know I'm done with that step. And now I do the same process that I did on the last problem. I say what's 3 times negative 4? That is negative 12. But I'm going to just treat it like a positive right now, because I want to know the factors of 12. So I have 1 and 12, 2 and 6, or 3 and 4. Now, if I have to multiply to a negative number, which I do here, I need at least one of my numbers over here to be negative. So I need, when I'm adding a positive and negative number together, they have to equal 11. The only two numbers that are going to give me that are 1 and 12. And if I need a positive 11, that means that I need a positive 12 and I'd have to just subtract 1 in order to get to that 11. So here I can make my box. Again, you always start with the first and last term. So our first term goes in the upper left, our last term goes in the lower right, and then whatever two numbers I used, I put in the remaining two boxes. The order doesn't matter, but that negative with that x really matters. That's a negative 1x. So if I look vertically, what does my first column here have in common? They have an x in common. And if I take an x out, I would still have 3x left, and I would have a negative 1. Now if I look over at this column, if I pulled out a 3x over here, I would have a 4 left. 3x times 4 would give me that 12x. Then I check, is 4 times negative 1 a negative 4? Yes, so I know my answer is correct. So I'm going to say 3x minus 1 times x plus 4. And if you ever want to check this, it's really easy. We just use what we learned in chapter 7, and we can FOIL. So I can say 3x times x is 3x squared. 3x times 4 is 12x. Negative 1 times x is minus x. Negative 1 times 4 is negative 4. And if I simplify, I only have one x squared term. 12x minus x is 11x. And then I only have one constant. So I have 3x squared plus 11x minus 4. All right, let's take a look at example 2, where we have some minus or some subtraction happening in our formula. So again, I start by multiplying the first and last term. So I have 2. My factors of 2 are just 1 and 2 because 2 is prime. And I know that they need to add up to a negative 1. So that means my 2 needs to be negative, my 1 needs to be positive. So if I draw my box, I have my 2n squared, and I have my negative 1. And then I need to put in my numbers, my factors. Okay, so I again start with the vertical. I say, what do those two things have in common? They have an n, so I'm left with a 2n over here and just a 1 here. And then if I have a 2n over here on the left, and I want to know what do I have to multiply by to get negative 2n, that would be a negative 1. And to check to see if I am correct, I can just say, is 1 times negative 1 a negative 1? It is, so I know my answer is correct, and I can say 2n plus 1, that's what I have over here, they're both positive, times n, and then I have a negative 1. So that is my answer for that first one. If we move on to letter B, I look at this and I say, hey, they all have something in common. They all have at least 5 in common. So if I divide everything by 5, I'm left with 2y squared minus 7y plus 15. And then from there, I can, oh, not 15, my bad, 6. And from there, I can solve it. I actually want you guys to see if you can try this problem and solve it on your own. Good luck. All right, so let's walk through this problem and see if you got it correct. So I would, after dividing everything by the greatest common factor, I would say I need the factors of 12. So my factors of 12 are 1 and 12, 2 and 6, 3 and 4. And those factors need to add up to a negative 7. So that means I need a negative 3 and a negative 4. So if I draw my box, I have a 2y squared, I have a 6, and then I have negative 3y, and I have a negative 4y. If I look vertically, these two boxes have a y in common. I'd be left with 2y here, negative 3 here. And then if I go horizontally, 2y times what gives me negative 4y? That would be a negative 2. And then I need to check, is Negative 3 times negative 2, a positive 6? It is, so I know my answer is going to be 2y minus 3 times y minus 2. All right, if you have questions about that, please be sure to reach out for some help. All right, now let's talk about how to determine if a polynomial is prime. So first things first, you want to look and see, is there a greatest common factor? So we have a 4, negative 1, and a 7. So there's no greatest common factor, so I jump right in and I say 4 times 7, that means I'm looking for factors of 28. So that would be a 1 and 28. 2 and 14, 3 doesn't go into it, but 4 and 7 do, and then 5 and 6 don't go into it. So those are all of my factors. And is there any way that I can add, if I have a positive here, that means that I have either 2 positives over here, or I have 2 negatives over here. So I could either have a positive 1 and 28, that would give me 29. That does not match the negative 1 I'm looking for. Or I could have negative 1 minus 28. That's negative 29. Still doesn't match what I'm looking for here. 2 and 14, I would either end up at positive 16 or negative 16. And then 4 and 7, I would either end up at 11 or negative 11. So there's no way for me to get that middle term. That means that this polynomial is considered prime. Nothing multiplies into it except for 1 and itself. Okay? Now let's look at the next polynomial. I want you to look and see, is this polynomial prime? If it is, just write prime. If it's not, I want you to factor it. Good luck. All right. For this problem, hopefully you saw that it is actually not prime. You can factor it because I was looking for factors of 10 that then add up to a positive 3. So if I did a negative 2 and positive 5, that means that I can factor it. And I'd be left with 2x plus 5 times x minus 1. All right, now let's do our last example for this video. We want to solve equations by factoring. So same idea as before, but this time we're just going to look at a word problem. So if we have a person that throws a ball upward from a 506-foot tall building, the ball's height h in feet after t seconds is given by the equation. H equals negative 16t squared. So moving forward in math and science, you'll find out that when you're talking about feet, negative 16 is going to go along with your gravity. Like that represents gravity. It's how fast it's being pulled back to the earth. So you'll see a lot of negative 16s, or if we're talking about meters, it's negative 9.8. Okay, and then so the equation is negative 16t squared plus 48t plus 506. That 506 represents however high the object starts. And then we know the ball lands on a balcony that's 218 feet above the ground. How many seconds was it in the air? So the way that we solve this is we know it ends up at 218 feet. So I say 218 equals negative 16t squared plus 48t plus 506. And with all equations, I want it set equal to 0 so I can solve it. And so I'd have negative 16t squared plus 48t plus 288. I notice that all of those numbers are even, so if I divide, so 0 divided by, let's see, what number goes into all of those? 8 for sure does. 16 actually might too. If we divide everything by 16, 0 divided by 16 is still 0. I'd be left with negative t squared plus 3t plus 18. And then, from there, one important thing to note is we don't like to factor when we start with a negative. So what I'm going to do is change the sign of everything. So 0 is kind of the special case. It's not positive or negative, so it just stays. But then my t squared is going to be positive. I'm going to change it from a plus 3t to a minus, I'm going to change it from a plus to a minus 18. Now I have t squared minus 3t minus 18. Okay, I'm back to the nice problems from yesterday where I have a 1 value there. So I would just say what two numbers multiply to 18. So I have 1 and 18, 2 and 9, 3 and 6. And then add to a negative 3. Well, that would be a positive 3 and a negative 6. So if I do my box, I would have t squared. I would have negative 18 here. I would do plus 3t minus 6t. They have a t in common. I'd be left with t and a positive 3 on the left. I'd be left with a negative 6 on the right. And if I check, negative 6 times 3 is negative 18. So t plus 3 times t minus 6 equals 0. Don't forget to set it back up to the equation. And then I am just going to say t plus 3 equals 0. I take everything inside my parentheses. T minus 6 equals 0. Again, everything in my parentheses. Set it equal to 0. And I get t equals negative 3 or t equals 6. So t equals negative 3. That means it was in the air for negative 3 seconds. Does that make sense? Can we have negative time? No. So we get rid of that answer and we say the ball was in the air for 6 seconds. Okay, so if you have any questions at all on any of these problems, please be sure to ask for some help, and I'd be more than happy to assist you. Have a wonderful day.